Sometimes more than one correct Lewis structure can be drawn for a molecule. Let's draw the Lewis structure for NO3-. NO3- has 24 valence electrons. So when we draw the Lewis structure for NO3, we start by placing the central atom in the middle and draw it bonded to all of the other atoms. We've now used 6 electrons. Then we fill in the octets of the atoms, saving the central atom for last. At this point, I've included all 24 valence electrons. So what's wrong with this structure? What you'll notice is that nitrogen doesn't have an octet of electrons. And so to give nitrogen an octet, we will move one pair of electrons from one of the oxygen atoms in to create a double bond. Now all of the atoms have an octet. But did I have to move the electrons from the oxygen on the left to create a double bond? And the answer is no. I could have created a double bond between nitrogen and any of the oxygen atoms. And these equivalent structures are called resonance structures. Something that's important to remember is that resonance structures differ only in the electron pairs and not in the placement of atoms. If you change the placement of atoms, then you're changing the actual molecule. The other thing to remember is that Lewis structures are just representations of the actual structures. And so the actual structure is a hybrid of these resonance structures. So if I had a collection of NO3- molecules, I wouldn't see the double bond between nitrogen and oxygen in varying positions. In fact, I would see all equivalent bonds between the nitrogen and oxygen atoms. And this is because instead of that double bond existing between one nitrogen and one oxygen atom, it's actually shared between all 3 oxygen atoms. And so it's sometimes helpful to compare resonance structures to mixing different colors of paint. For example, if I were to mix red paint and blue paint, I wouldn't have paint that oscillated between red and blue, being red sometimes and blue sometimes. I would have paint that was purple, that was a mixture of the 2 colors. And it's the same way with resonance structures. I don't see this double bond switching positions in different molecules. The structure is actually a hybrid of these 3 structures, and we just draw them all out separately to represent this. How many resonance structures are possible for the molecule SO2? SO2 has 18 valence electrons. When we draw the structure for SO2, we start by placing the central atom in the middle and draw it bonded to each of the oxygen atoms. Remember that there are 2 electrons in each bond, so as of now I've used 4 electrons. Then I start by filling in the octets of the remaining atoms, saving the central atom for last. So this structure includes all 18 valence electrons, but sulfur doesn't have an octet, which means that we need to move 2 electrons from one of the oxygen atoms in to form a double bond, giving all atoms in the structure an octet. But this double bond could have been placed between sulfur and either oxygen atom. So in this case, the molecule SO2 has 2 resonance structures. And again, remember that the actual structure for SO2 is actually a hybrid or a mixture of these 2 structures.